Hello everyone and welcome to my YouTube channel. My name is Subhashish Mishra and today's topic of discussion is visualization using Matplotlib. If you are new to my channel, please subscribe, like and turn on the notification bell so that you will be notified whenever any new video gets uploaded, as I'm constantly uploading videos on machine learning and data science. Now let's get started. So here we are in the Jupyter notebook, and as far as the topic of discussion for today is Matplotlib. By default, Matplotlib doesn't come with the Python distributions. Alright, we need to install it separately. So to install Matplotlib, we have to type commands like run in terminal or any kind of in this Jupyter notebook also. I'll show you right now. Like pip install Matplotlib, or if you have Conda distribution, you can go ahead and do Conda install Matplotlib. There are a lot of ways of installing Matplotlib. You can go ahead and simple open the command prompt and then do pip install Matplotlib and it will install for you. Okay, in my case the requirement is already there because I have already installed Matplotlib. That's why it is saying requirement already satisfied. But in your case, it will go ahead and install the Matplotlib. Okay, you can also be able to install Matplotlib using Jupyter Notebook. The notebook wherever you are working, you can be able to install Matplotlib also. Alright, so you can be able to do that in this way. Pip install Matplotlib. Same thing that you have done in your command line interpreter. Over here, only one thing you have to add is like this exclamation mark. If you do that, then this cell will work like a command line interpreter. Okay, I'll show you. Alright, as you can see, requirement is already satisfied as I have already installed Matplotlib. Alright, let's get started. So, to visualize anything, we need to have a data set available with us. Okay, so let's create a data set. Let's first import numpy as np import. Now let's import Matplotlib. Matplotlib dot pyplot, because we're doing this for Python, right? So dot pyplot as plt. Now the installation is done. Okay, so if you're working in Jupyter Notebook, then without any kind of show method, okay, Matplotlib has a dot show method using which you can be able to showcase your plotting that is being done. But in case of Jupyter Notebook, we have an extra privilege is like if we will be doing Matplotlib inline, then we can be able to visualize it. We can display the visualization without using plt.show. Okay, what I mean by that, you can be able to go understand whenever I will do the plotting over here. Matplotlib dot inline. So this is the command using which we can be able to plot every plotting in the Matplotlib without using plt.plot. Okay, now let's create a two numpy arrays, okay, using which we can be able to plot the differences or anything else we want. So let's say that there is a numpy array called as x, and creating the numpy array as np.linespace, and the start, as you already know, let's say it's 0, stop, let's say it's 10, nums is 5, total number of inputs removed is 5, y is equal to x square of x square is called as y. Okay, so this whatever we have done over here, this is the part of NumPy lecture that we have done. If you haven't already watched it, I will encourage you go ahead and watch it so that you can be able to correlate with this one whatever we are doing over here. I'll link it in the I button of above and also in the description below. Alright, so the two NumPy arrays are being created. Okay, now let's go ahead and check it out. X 0, 2.5, 5, 7.5 and 10. And y is 0, 6.25, 25, 56.25 and 100 is just the square of the x. Now, if we want to plot it, simple statement that we can be able to do is like PLT is a short form that we have created for Matplotlib. So we can go ahead and do PLT.plot and we can plot the difference between x and y in a xy plane. Okay, so this is a simple plotting that we can do. If you are using any other editor apart from Jupyter Notebook, you have to do plt.show. Like once you have done this one, you have to do plt.show to showcase your plotting. Okay, so that will also work in Jupyter Notebook, but in Jupyter Notebook, as far as we have written Matplotlib inline, then we don't have to provide the plt.show. It will always showcase our plotting. All right. Now, if you want to add any kind of label into it, okay, like we want to add X label and Y label, then that is also possible. So plt.plot is what we have done X and Y, and plt.x label. It's pretty much simple. Let's say X is the label that we want to add. plt.y label. And let's say y is the label that we want. Okay, once we do that, we can be able to see that it has assigned the x label and y label for us. Okay, now we can also be able to add title into it. Again, the command is pretty much simple. plt.title, and let's say my title is ML is easy. Then it will showcase me the title above. As you can see, ML is easy and Y and X label also. Alright. Now, there are certain plotting available. Is like this is one single plot that we have done. Okay. If we want to create any subplot, like 2-3 plots we want to create in a single plane, then we can also be able to do that. Okay. So for that, we have to create subplots. plt.subplot and the number of subplots we want. It takes the number of. So if we do shift tab, then we can be able to check what kind of argument it takes. Okay. Let's go ahead and check any kind of example available over here. Okay. See plt.subplots 2, 1. Okay. So the first argument is number of rows. This 2 is number of rows. Okay. This 2 is number of columns we want. And the third one is the one we can be able to see, like the plot name that we want. Okay, what is the name of the plotting that we want? Okay, so let's say we have given a plotting like number of rows is 1, number of columns is 2, and the plot name is 1. This is what we want. Okay, now plt.plot x and y. Let's plot x and y. Once we do that, we can be able to see that there are 2 plotting available over here. Okay. Alright. We can also provide different colors to distinguish. Okay, the plotting color. As we can be able to see that over here, the color is blue, both the cases. Okay. We can be able to change it. The simple command for that is, let's copy the whole set of code that we have done over here. In X and Y, we can be able to specify the color name. We can have the keyword argument or just the runtime argument. Okay. Alright. Now you can be able to see that the first one is red, the second one is green. Okay. So So this is how you can play around with the color sequences also. There is another way of plotting using Matplotlib, which is called as object-oriented method. So this is a simple method of plotting a Matplotlib. Okay, there is another better way of plotting, which is called as object-oriented method. Okay, which is very much used. Okay, for that we have to define a figure or a canvas, you can say, on which we can be able to draw the plot. Okay, so for that, what we can be able to do is like fig is equal to plt dot figure. It's very simple. Once we do that, we are being able to create a figure, okay, a plane or a canvas onto which we can be able to plot. Okay, now once we declare the fig variable, we can be able to create and go ahead and add the axis. Okay, so let's say axis is fig dot add axis. Sorry, I'll explain this. What are these things? Point 1, let's say, and then point 8, let's say, and point 8. Okay. So this is the fig, the canvas that we have. Okay, and whenever we are adding an axis, that means we are making a draw or a plotting in a specific region of that fig or the canvas that we have plotted. Okay, so in that case, here whatever we are specifying is like four values: left, bottom, width and height. This is left, this is bottom, this is width and height. This is the percentage. It is the 10% of the fig, it's the 10%, and it's the 80%, it is the 80%. Okay, so it will go ahead and create a sub canvas for us inside this canvas fig, having left, bottom, width and height as 10, 10, 80 and 80%. Let's go ahead and do that. Once we do that, we can be able to see that this is the axis plane that we can be able to create. Now we can be able to go ahead and plot using this axis. Okay, so axis dot plot, just like the way we have done in the plt dot plot, x and y. And as you can see, is plotting us the details in this plane that we have specified. Okay, now we can also be able to do the x label, y label, title using that. Okay, for that we can be able to do the same using axis dot set x label. The command is little bit different over here. We have to, in that case, we have it like plt dot x label, plt dot y label, right? As you can see. But here we have to specify it as set x label and set y label. You can also be able to provide the x label and y label as the same one that we have done before. Set y label y, and also we can be able to provide the title. Again, the same thing is set title. Same title that we had before. And once we print that, we can be able to see that we have the x label, y label and the title. Okay, so the object oriented method is a better option because we can be able to change it whenever we want, and we don't have to go ahead and change it in every spaces that we want. Okay, it can be reusable. Whenever we declare the fig object, we can be able to use it and we can be able to plot different ways. Okay. We can also able to create multiple figures using the object-oriented approach. As we have done the subplotting, we can be able to do the subplotting in object-oriented approach also. Okay, for that, the same thing we have to do is like fig is equal to plt dot figure is the object that we have to create. Once this has been done, we can be able to add the axis. Let's say axis 1 is the one that we want to specify. It's like fig dot add axis as usual, and 1, 1. Made a mistake. 1, 1, 0.8, 0.8. Alright. So this is the axis number 1. Okay. And we can be able to say that axis dot set title to separate them. Okay. So axis 1. Let's say we have the title as axis 1. We can be able to do the same for axis 2 also. Only thing we have to change is like we have to change this percentage of the left, bottom, width and height. Okay, so here we can be able to specify like let's say 50% of left and 20% of bottom, 30% of width and 30% of height. Okay, and let's say set title is equal to axis 1, axis 2, this is being done. There is an error. What is it? Axis subject has no attribute set tile. Oh, I have missed one D over here. Set title. Now we can be able to see it. Okay, here we have two plots that we have done, axis 1 and axis 2. Okay, and this is a bigger plot, this is a smaller. Okay, we can also be able to plot the x and y using this thing. Okay, so for that we have to do one simple thing is like axis 1 dot plot x comma y. Let's do it y comma x. Let's change it a bit. Axis 2 dot plot x comma y. So once we do that, we can be able to see that plotting has been done. Alright. Okay, so over here also we can be able to specify the second approach of creating the subplots using plt.subplots. Okay, the way we have done before. So here we have to specify the object name as fig and axis, and plt.subplots is what we want to specify. So here we have specified fig and axis is the combination of a tuple. Okay, fig is the fig object and axis is the number of subplots we want to print. Okay, so once this has been created, let's go ahead and specify the number of rows and columns we want to create for the subplots, as we were creating number of rows and columns in the subplot, right? See, rows, columns, we have specified that. So we can be able to do that. The only thing is which is different is that we are not specifying the name. Okay, let's say the n rows is 1 and in columns is 2. If we do that, we can be able to say that we have two subplots specified over here. Okay, now we can go ahead and check out what is the axis. Once we see the axis is axis subplot, so 1 and 2, it is a array of lists. So we can be able to specify two axes because there are two columns, so we can be able to specify two axes over here. Okay, by default it is one row and one column, by the way. So we can be able to specify so we can be able to iterate through the plots and we can be able to print it or plot it. So we can be able to do is like for I in axis, okay, I dot plot x comma y, and it will print us xy plane in both the subplots. Okay, now if we want to do the same thing but we want that in one subplot it should be x and y, another subplot should be y and x. So for that what we have to do is we can do one simple thing is like axis of 0 as we do in the list annotation. Okay, dot plot x comma y, axis of 1 dot plot y comma x, and it will plot us x and y and x based on the requirement that we have. Subplot that we are creating over here, and we are creating as like 3 rows and 3 columns, so 3 cross 3, so there will be 9. So over here as you can see, the it is overlapping, one is overlapping another one. Okay, so to deal with that, we have a specific method in Matplotlib called as plt dot tight layout. If we use tight layout, and you can see it has separated each and every one properly and nothing is overlapping right now. It's like we can be able to specify this fig size also. Okay, so fig is equal to, let's say, plt dot figure is what we are creating over here. Now in plt dot figure we can be able to specify the fig size also. So if we specify fig size is equal to, so once we specify the fig size, then we can be able to draw the plane the way we want it. Let's say 2,5 is the fig size that we want, and let's say create the axis fig dot add axis, let's say 0 0 1 and 1. This is what we want. Once we do that, we can be able to see a plane which is being 2 by 5 fig size. Okay. Now here also we can be able to do the same thing that we were doing in the plotting. Axis dot plot x, y, and it's showing us xy plot. Now we can have the subplots over here. Okay, so thing that we were doing in this subplot, let's copy it out. We can be able to create a subplot, create 2 subplots, but here we can be able to use the fig size also. So let's say we have the fig size which is it's a 7 by 2. Okay, so once we see that, we can be able to see this is the 2 plottings that is available for us. Okay, so if it is little bit closer with each other, then we can be able to specify always is like tight layout, and it will separate it a bit. Okay, it's more clearer. All right, we can save the figure whenever we are creating any kind of figures. We can be able to save the figure. Okay, so as you can be able to see that fig is what this is one is the fig. Okay, we can be able to save the figures like dot save fig, and we can be able to specify the name we want to save. Let's say png file format, or jpeg file format, svg file format. It can be able to save in any file format you want. It's a test1.png I want to save, so it has saved me using test on the png. Okay, now let's discuss about legends. What is legends? Okay, so whenever we are creating any kind of plotting, okay, so this is what is called as legend. The entire line what you can be able to see over here, this is called as legend. Okay, so if we have, let's say we want to plot a figure in this way, we have the fig size as 8,2, and axis, let's say fig dot add axis, 0011, and now axis dot plot x, and I want to plot x square over here. Okay, and then we also want to do axis dot plot x comma x cube. So let's do that. So once we do that, we can be able to see there are two planes or two plotting available over here, but we can't be able to specify which one is square and which one is cube by just looking at it. Okay, so here comes the concept of legend. If we have the legend, then it will specify us that which one is cube, which one is square. For that, we can be able to do one simple thing is like axis dot legend. If we do this thing, what is going to happen? It's showing that no handles with label found to put in legend. Okay, so once we call the legend object, once we call the legend method, then it will go ahead and look out for the labels from which it will fetch the legend. So it is not finding any label in both the plotting. That's the reason it is showing no handles with label found to put in legend. So here we can be able to specify the label as such, which is like square. Here let's the label is cubed. Now we can be able to see that the legend is already being provided. Here you can be able to see the blue one is the square and the orange one is the cube. Okay. Alright. Now we can be able to know which one is square and which one is cube. Right? By looking the legends. Alright. Now let's discuss about color. Okay. So here we have the legends is like blue and the orange. We can be able to change it based on our preferences. Okay, so we can be able to specify over here is color is equal to, let's say I'm specifying it as green, and I'm specifying it as color is equal to red. Okay, once I do that, I can be able to see that the square one, the legend for square is green and the legend for cube is red. Okay, we can be able to specify the color by using any kind of hex code also. Okay, RGB hex code that we usually use to denominate any kind of color, we can be able to use it. Okay. So let's say that has 32A 852. Let's say I'm specifying this color. What is it? Green. Yeah, it's a green. Okay. Alright then. We can also specify the line width. The width of the line over here, the legend lines, is by default 1. We can be able to change that also. Okay. For that, what we have to do is like, let's say we have a, we can be able to do it over here also. Line width is equal to, let's say I'm specifying it as 3. Okay. Now you can be able to see that the square line is thicker than the cube line. Okay. If I'll do it 0.5, then you can be able to see that it is more thinner than the cube line. Alright. Now we can also be able to provide one more command called as alpha. What is alpha? Is like it just, I will show you what is alpha. Let's create a example out of here. Say alpha is equal to zero point 0.5. Once I create this, let's first just see it without alpha. Okay, whenever we don't have alpha, we can be able to see that the green line which is being plotted over here is very much dark. Okay, once we add the alpha, the green line became lighter. Okay, so it is being used to provide any kind of light or dark shades what you want to provide. Okay, we can be able to make the style change of the legend. So here we can be able to see that the legend style is a straight line or a line. Okay, if we want to change it into star, or if we want to change it into any dotted plots, then we can be able to do that also. Okay, for that, let's say I'm doing the line style. For that, I can be able to use line style. Let's say I want to create it using dotted. So here you can be able to see that the green line is dotted, the squared line is dotted. Okay, now one more thing we can be able to do is that if we want to get the point location on the plot, then we can be able to do it by using markers. So let's say we have the x 0, 2.5, 5, 7.5 and 10, and also so we want to see that the point and the y is like this one. So we want to see wherever it meets there should be a specific dot or a point to denominate that this is the point wherever they are meeting. Okay, so we can be able to do it using the marker. Okay, let's say fig is equal to plt dot figure fig size is 8,2. We have now, so we are creating axis is equal to fig dot and axis is 0, 0, 1, 1, and axis dot plot we are creating x comma 1. So that's it. This is what the plotting is. Okay, now we want to know the line or the dotted points wherever the x and y meets. Okay, so we can be able to specify it over here using markers is equal to, let's say we are specifying it as O. O means it will specify a dot. Once we do that, we can be able to see that there is a dot present in every meeting point of x and y. So O is the basic marker which specifies the dot points. We can be able to add plus also, star also. There are a lot of ways of doing it. So it is star now for the marker. Okay, we can be able to increase or decrease the marker size also. So let's say we have these stars and we are not being able to properly see those stars. Okay, so we can specify the marker size, which is, let's say 5. Okay, by default it is always 1 as usual. Can be able to see it is a bit better now. Okay, say 10. Now we can be able to see it is really bigger stars and we can be able to see them. Okay, now we can customize the marker as well as adding the marker color. Okay, whenever we have the dot, let's go back to the dot. We have, okay, so whenever we have the O marker, okay, we can be able to specify the O. I mean the inside we can be able to specify one color. We can be able to have a specific color for the width. We can have the thickness of the width. All of these things that we can be able to change also. So how we can be able to do that? Like let's say this is the marker size and marker color marker face color. I'm sorry, marker face color. So which will be inside this circle. Okay, marker face color is, let's say, red. Now let's try. See, you can be able to notice that the marker face, the inside part of the each marker is being red. Now if I want to change the marker edge width, okay, I want it to be more darker or more vibrant so that we can be able to see it. We can be able to do marker edge width, which is, let's say, 2. Now we can be able to notice the width has been little bigger and more thicker. We can be also able to change the edge width color. This edge width color, if we want, we can be able to change. Marker is width color is equal to, say, yellow. There is some error. What is it? Line 2D object has no property called as marker is width color. Okay, we have done some mistake. Width, not a width color, marker is color. Okay, once we do that, we can be able to see that the marker is has been modified into the color as yellow. Alright, so this is the pretty much basic about Matplotlib. We will be definitely using another one, visualization, also, wherever we will be seeing the box plot, the bar graph, the pie chart and all. Those are also available in Matplotlib, but Seaborn is the better tutorial for that, and Seaborn visualization is the better technique for that. So we'll be discussing Seaborn visualization in the next tutorial. And until then, stay tuned and enjoy machine learning. Thank you so much.